Hello everyone, today I'll be demonstrating homework number 2. Homework number 2 asks us to use the turtle module to draw a four-sided inward or outward going spiral. Over here we have two spirals depicted over here. As a challenge, we were given to draw this one and have come up with the code for all three, and I'll be demonstrating that today. Over here is the code for the first one. The first one pretty basic. Over here I have the call function, and take notice that I'm using this token over here, and what this token does is that it makes it that it calls every function in this library, in the turtle library, so that I don't have to put turtle.screen or turtle.turtle, and that really saves time. So I defined outward spiral maker using these three parameters: bg equals screen, bg.bg color, and bg.title, and I have the values in here for them. So bg equals the window where the turtle will be running in. John equals the turtle, and John's speed is 0, which is the fastest. Over here we have the loop function for I in range number of sides, which is one of the values that the user puts in. John.forward beginning size plus I times change, where beginning size is another parameter that the user puts in, and change is also a parameter that user puts in. And John dot left 90 degrees, which means John will be turning left 90 degrees depending on whatever his orientation is going to be. So we quickly notice that this causes the steps to increase with each iteration of the loop function, and let's look at what the module will do. Okay, I've ran the module. As you can see, the turtle starts from over here and is going outwards, and as you can see, the steps are increasing as he's going outwards. So basically he's actually escaping his it could be seen as him escaping his little cage over here. The second one is where we're making an inward spiral. The inward spiral is very similar to the outward spiral, but it uses a different kind of aspect to it. The biggest difference between these two is that John is not actually moving beginning size plus I times change, but is moving beginning size minus I times change, which makes the steps taken less and less with each iteration of the loop function, making it that John is being moved to a smaller position, which is what the inward spiral is. Over here I have a few conditional statements, and these conditional statements I'll talk about them a bit more later, but basically what they do is that they make the final product a function that is just a set of inner spirals. Over here I have a few lines of code that basically dictate where the turtle John would start, and I did this for fun. This statement over here makes John start from a position where his final position is going to be at 0, 0. And to do this, and to make sure that the user can't see it, I've added these statements over here. The first one hides John. The second one stops John from drawing. The third one starts John. And the fourth one shows John. And this is because when you set John to a position, John will be going there, showing itself while making a line. So that to guard against that, these statements are needed. Also, these conditionals over here are a direct effect caused by this function over here, because if we know that beginning size is greater than I times change, it has to be that these values are correct. So all these three values don't have to be inputted. One of them could be none, and the other one could be found with basic algebra. And and as we can see, um, the number of sides is not that significant as compared to beginning size and change, and that's because if we have all of them in there, number of sides, which only controls the range, is in direct conflict with this if function, and if this number of sides is larger than the I that satisfies this, then that number of sides is not going to be included. But the I that satisfies this function will be included. But if number of sides is less than the I that satisfies this, it would be that the number of sides will be included, and it will not make a complete spiral, of course, unlike these statements over here, which would make a perfect finished inward spiral. Okay, let's try this out. Let's run the module. As you can see, the final position is at 0, 0, and the turtle starts from outside and is moving inwards, and as you can see, it's a perfect inward spiral. It looks pretty good. Okay, let's try the third one. The third one is very similar to the second one, as it uses the same kind of function, as you can see, and the biggest difference and the only difference between two of them is that this one doesn't use an if function, but the other one does, and this if function causes a big change, and we'll be seeing it when we run this. As you can see, the turtle is making an inward spiral at first. This is where where beginning size minus I times change is 0. We can see that now turtle is going backwards. As you can see, a different shape was produced. It started with the same shape, but then it started producing another shape. As you can see, this is because when beginning size is less than change times I will take over, and this will be a negative value, which means that it's going to be taking negative steps, and negative steps in Python transfers to John moving backwards. Also, this could be the analogous condition would be John dot backwards change times I minus beginning size, and as we can see, this is a very cool trick over here. So I wanna compare this to this over here, because as we can see, the only difference between these two is that plus sign over there, and just because of that plus sign, we're seeing two different shapes, and to really examine why, we have to see and notice that this causes the steps to increase while this causes the steps to decrease, which means that it would be making an inward spiral. But this one, once it hits that point where beginning size is less than where beginning size is equal to change times I, it would be that this would be negative, causing a different kind of shape, unlike this one, which is going to be a constant shape, just regular old John going around that spiral. But this one really causes a more sophisticated and interesting looking spiral, which is very cool. Thank you for watching this video. Until next time, see ya.